Great job. Okay, so a couple people have talked to me between the breaks, and they say, wow, that stuff's looking pretty interesting. You got a lot of cool stuff going there. So just what parts, though, are the mock-ups and which parts are the real parts? And the things that I want to emphasize here is that everything that you've seen to date, everything that's running is running on the real code that you're going to get tomorrow. So this stuff is all real. It's all been built. So a couple of quick summaries of what we've seen, and then we're going to go into the orchestration piece. So what Anders talked about, he talked about how this technology is now web to the core. We've got XML, XSL support deeply integrated throughout the component model. You saw how we used web services operating off of Unix devices. Unix devices can use our web services. There's a unified programming model that gives us a consistent way to program an application, whether you're targeting a PDA or a cell phone, up through offline applications, through rich web services and web applications, all the way up to the offline capable application and components. It's also multi-language. You saw in the same shell, using the same debugger, VB and C#. We saw those things inheriting from one another. It's all deeply integrated, so if you target that common language runtime, you're going to see all the benefits of those things for your languages. So I think that you probably have a good understanding now for that in the large picture about how web services can be aggregated together to build applications. And we've gone inside to see how the low-level pieces build up to that bigger story. What we want to do now is talk about how you would orchestrate a set of web services together. Now, let's say that you've created a web service and they've created a web service and there's a whole bunch of web services out there and we want to go create an application. So typically what developers have had to do is do things like this. They may get some data from the user, and they may talk to one of these services. Maybe they do that in parallel, and they say something like, when I get the data back, which is the credit card validation, then I'll talk to the fulfillment house. But maybe the fulfillment house has a problem. Well, what are we going to do about that? How are we going to reliably respond to it? So what developers have had to do is they've had to build state machines. The state machine keeps track of where in the process the current application is, and as new events occur, they advance through that state machine. But as the problem becomes more and more complicated and there's failures in the system, and you want this whole process to be very, very dynamic in response to the business process folks, how are you going to coordinate all that stuff? Well, we've provided a set of technologies in the orchestration space. BizTalk Server is going to provide an orchestration engine that will take a description of the business process, which is captured in an XLang document, and we have a set of tools to help you capture that business process flow and directly execute that using the business process engine, this orchestration engine in BizTalk Server. That, in turn, is going to drive a set of transformation and transport engines that can talk to web services, MSMQ, and out to legacy systems and to interoperate with all kinds of other things, as well as existing COM+ components. So the person who's going to come up and talk to us about this is Amit Mital. Amit has been at Microsoft working on enterprise server technologies for a whole bunch of years. He's started with MTS. He led the COM+ Services Program Management team, and now he's the general manager for the BizTalk Server team. Please welcome Amit.
Thanks, John. Good afternoon. My name is Amit Mital, and I run the BizTalk Server Orchestration team. So today, I'm going to talk about the challenges that we developers face when we build business applications for this new generation of the internet, this third generation that Paul talked about today. Now, throughout the day, you've heard about web services and how that's our vision for the future. And we believe that web services are going to be enormously popular. There are going to be hundreds, thousands, tens of thousands of web services published by developers like you exposing rich services that I can use in my business application. And in this new world, it's going to be very loosely coupled, message-based, and typically very asynchronous as well. And so the challenges of orchestrating all these web services are very significant. And this is where .NET orchestration has a huge part. Now, in addition to these web services, you also have these legacy components, these legacy systems, in which all your data resides today. And it's not really going away anytime soon. And you also have all these middle-tier components, components in COM, in MTS, which have tons of middle-tier logic, of business logic. And you need to integrate all this stuff together. Now, in the past, you could build a business application in a very tightly coupled way. You build on one server, maybe a few clusters of servers. And fine, you had a tightly coupled synchronous system. You wrote a bunch of code, everything was great. But now you have these asynchronous systems, message-based, loosely coupled. And you've got messages coming in from everybody, web services, your partners, your business partners across the internet. And you need somehow to coordinate all these messages together into your business application. Now, the way people have dealt with it traditionally has been writing these really complicated state machines which represent the business process. And that's been difficult. And .NET orchestration is about providing easy tools and an advanced language to enable you to build a business process which meets these needs. So I'll talk about orchestration. What is it? Why do I need it? Does it taste great? Is it fattening? No, never mind. I'll talk about the tools and technologies that we provide for orchestration. So let's talk about the challenges that you face today. You need to integrate heterogeneous environments. So you have multiple applications and platforms. Your business partners across the internet are very often running on a different platform than you are. They're running different applications than you are. They probably have different data formats than you have. And you need to integrate all this stuff together. You need to integrate with your business partners across B2B exchanges, across the internet. At the same time, you need to leverage your existing IT investments, your legacy systems, your middle-tier components, all the stuff you've been building for a long time. Of course, the internet adds another dimension to this. The internet has enormously accelerated the rate of change of business. You all know .coms come and go. Business processes evolve so rapidly. And that means the business applications that we write to enforce these business processes, the rules, the code, has to change at the same pace. And that's very difficult. We need to compete on web time. And finally, we need to build on XML. XML is this really powerful language for data exchange. It's self-describing. You can describe all these formats and they interoperate with each other. You can exchange data with your business partners in this very rich way. And then on top of that, you have SOAP, which is a very powerful protocol mechanism for accessing web services across the internet. So what are the solution requirements you need? Of course, you need a rich communication infrastructure. You need to be able to communicate across the intranet, the extranet, WAN, the internet, of course. You also need a very rich messaging infrastructure. So your business partners are very unlikely to have the same data formats as you do. Well, some people are using XML, and more people are using XML. They're recognizing how powerful it is. But people still have lots of formats in flat file, in some binary proprietary format, in EDI, and all these formats need to interoperate, need to translate between them. And fine, even if you are using XML, everybody has a different way of representing a purchase order or an invoice. And so you need to not just translate, but transform between these different schemas. And now you have data, you have your schema in you have your data in some schema. And now you need to send it to your business partner. And of course, security is a huge issue on the internet. You need to deal with encryption, both of the data and the channel. You need to deal with authentication. of yourself, of your data. And then you have all these protocols. So many protocols on the internet. HTTP is so popular, but so is SMTP, FTP, file transfer. And then you have MSMQ, you have COM, you have MQ series. The list goes on and on and on. And you need to be able to deal with all these protocols in a cohesive way, in a uniform way. You also need to be able to deal with synchronicity, synchronous and async behavior in a unified way. And finally, XML support needs to be built into your messaging infrastructure. And tying all this stuff together, all these messages flying in, synchronous, asynchronous, over HTTP, over COM, over MSMQ, is orchestration. So what is this orchestration thing? Orchestration is the integrating and coordinating of business processes that contain people, components, web services across organizations, applications, platforms. Now, I'm going to use a scenario to drive the demos you'll see in this talk. This talk is going to be about half PowerPoint and half demos. And so the scenario I'm going to use is a marketplace. And this marketplace is this website that I go to if I want to look for something to buy. Okay? And in the marketplace in the scenario I will talk about is the Dell Gigabyte site, which is a very popular site for buying accessories for my computer. And when I implement a marketplace such as this, I need to integrate applications both within my business and across businesses. I need to integrate partners. I need to implement standard business protocols. So the electronics industry has a supply chain standard known as Rosetta Net. And you need to implement things like the partner interchange protocol. And I'll talk about the Rosetta Net PIP during this demo. So to begin with, excuse me, I'm going the wrong way. Can we have the demo up, or is that on the other side? Oh, here we go. Unfortunately, I can't see the demo on my screen here, so I'm not sure I'm going to navigate this. Well, let's try this. Can I see my mouse? No. I'm going to try that machine. Okay, we are mouseless. Oh, here we go. Got it. Okay, we don't have cooperating systems here. It's a very loosely coupled system, you know. Okay, let's try this. Of course, we have help.
Other side.
Excuse me?
Other side.
Okay. Oh, the other side, sorry, left side.
He's on station.
I'm not sure how much I can say about this web page you're looking at. It's a very nice web page. Well, actually, let me just talk through it very, oh, there we go. Well,
All right, switches.
is the mouse working? Is the mouse?
Just one.
That was good. Thank you. Alrighty. Okay, so I've gone to this, this marketplace, and based on some criteria for my products, for the product I'm interested in, I see this web page. And now what I'm interested in looking at is what is the price, the best price and availability for a particular graphics card. And I'm going to pick the Oxygen GVX1. And a couple of seconds later, I get back a price and availability quote, which says, hey, you can get it for $637.95, and it's available within so many days. And this seems really simple. Just 2 mouse clicks, I get all the information I want, and that's great. But we all know that behind these 2 mouse clicks, there's a whole bunch of code being run, a whole bunch of applications being integrated, right? A whole bunch of business partners I'm dealing with. And let's look at that in some more detail. So I've got the user, and from his browser, he asks for price and availability from this virtual market. And the market turns around and sends this request to supplier A, gets a response back, maybe talks to supplier B, and so on and so forth. And then eventually the marketplace says, okay, I'm going to take all these responses, figure out what the best value is for my user, and send a response back. Now, in the implementation of the business process at the marketplace, clearly I need to access legacy information. And Host Integration Server is a great product for making it easy to access that information. Similarly, Commerce Server makes it very easy to publish an e-commerce site, to publish my catalog. Now let's look at the implementation of the application at the virtual market in some more detail. What are your challenges in doing this? Well, your first business challenge is that you have a constantly changing set of business partners. And not only are these guys constantly changing, but they have all these heterogeneous environments you need to deal with. So they keep coming in, they keep going out, and every one has a new format, a new protocol, a new address, all kinds of different things you need to deal with. And the technical challenge that results from this is that if you have a huge amount of schema out there. Everybody has their own schema, their own purchase order, their own invoice. Of course, everybody has their own protocol. Some guy likes HTTP, some guy likes MSMQ, some guy likes FTP or SMTP. Lots of e-commerce is done by email today. And of course, there's this ever-present data security issue. I need to encrypt my data. I need to authenticate it. I need to make sure nobody else can get at my data, my credit card information. And the .NET solution provides a rich set of EAI and B2B tools to enable this to happen. You can very quickly set up trading partner relationships with your partners, with your business partners, which are secure, which are reliable, and that can use multiple protocols. We also have a very rich set of tools for creating and manipulating schemas in XML and in other formats. And of course, creating schemas is not enough. You also need to map schemas from one format to another. And we have a very rich set of tools for enabling that to happen. Now, to demonstrate these tools, I'm going to ask Dave Washer, a product manager on BizTalk Server, to come out and demo this for us. Dave?
Thanks, Amit.
Done it.
Okay. So, as Amit said, there are a number of things. Can we switch to machine A?
Let me help you with it.
We got it. Okay, great. There are a number of things that you need to do in order to be able to orchestrate these applications together that are spanning applications and organizations, components, and web services. And one of the crucial things that enables you to do that is integration. Now, what I want to do today is show you some of the rich integration features for integrating applications, and features for integrating business partners that BizTalk Server 2000 provides you. The first thing that I want to look at is the BizTalk editor. This is where we can very easily and in a graphical way define XML schema that we want to use to send information back and forth, whether it be between applications or our business partners. Now, on the left-hand side, of the screen, you see a tree view of an XML schema. So we have a simple tree representation of the elements and nodes. The mouse is missing here. Of the elements and nodes of an XML schema. And we can, on the right-hand side of the screen, you see the attributes that are the attributes of the individual nodes of the XML tree. We can very easily add nodes to our XML schema simply by right-clicking, and we'll add a node called version. And we've added a node called version, and I want to indicate that node should be of type string. And I also want to enforce a minimum length of the node for 5 characters and a maximum length of the node for 20 characters. So there we very easily modified an XML schema. Now, we can either build the schema from scratch ourselves, we can import a DTD file, or we can take an instance of a schema, an instance that actually has data in it, import it into the BizTalk editor, and we can extrapolate from that the generic schema that we can then save and modify like I just did. So if we go ahead and save our schema, go ahead and save it out to our file. Take a look at it. And you'll see that it is, in fact, a well-formed XML XDR schema with support for data types, XML formatting, etc. So that's our XML schema editor that we provide in BizTalk Server 2000. But we don't, now that we can build our schema, we need to be able to often translate between our schema and the schema that other applications are using or that our business partners are using. And in order to do that, we use the BizTalk mapper, which allows us to very easily, in a graphical way, build the transformation or the XSLT file between 2 different schema. Now, on the left-hand side of the screen, you see our source document. This is the document from which we are going to transform data into what you see on the right-hand screen, which is our target document. In the middle, you see how we graphically do this translation, how we graphically create an XSLT file by dragging and dropping elements from the source document to the target document. So we can very easily just do a straight pass-through where we just send the data from a node in our source document straight through to where it should live in the target document. But often we want to manipulate that data before we actually do the transformation. And to do that, we use little macro scripts that we call functoids. So, for example, let's say that if I have ship method in my source document, and I want it to connect it to the version identifier in my target document, but I need to make sure that all of the data that I'm transforming is in uppercase or in capital letters. Well, we have a set of string function functoids that allow us to very easily do that. So we want to take a look at our functoid palette. I'll drag on my capitalize functoid. I'll connect the 2 together. And now, when I do this translation between my source document and my target document, that data that's coming from the ship method node is going to be capitalized before we do the translation into the target document for the version identifier node. Now, you'll notice that we have a ton of these functoids pre-built for you. We have mathematical functions, logical functions, date, time. We have scientific, cumulative, database functions. And this is also extensible. You can build your own functoids into this for operations that you frequently do when you're doing your transformations.
That's very cool.
So we've done our visual translation. Let me show you what we actually generate. We actually generate an XSL file directly from this visual representation. So there you can see that we've actually generated an XSLT file from our visual mapper in BizTalk. And if you've ever tried to program XSL before, you know that it's not an easy thing to do. We make it as easy as dragging and dropping elements from one to another. So we've built a schema in our editor. We've done a transformation from one schema, from a source schema to a target schema in our mapper. Now we need to actually exchange information either between applications or organizations. And to do that, we use what we call the BizTalk management desk. Now, this management desk makes it very easy for me to create trading partner relationships with my business partners or application integration relationships between applications. and we make it as easy as filling out a wizard. The first thing that we need to do is create what we call a port. Now, a port is a source of information from an application or an organization, or a destination for information in an application or an organization. And the first thing we need to do is create one of those. So what I want to do, since Amit's been dealing with the supply chain scenario, is create a port for what we call supplier 2, or supplier A. We'll create this port, and we need to define the organization where this information is going to be going. In this case, we're sending our information to our marketplace. We need to indicate what transport it is that we want to send this information over. I'll choose HTTPS. And we need to indicate where is the actual URL, where is the actual destination where we're sending our data and our documents. We'll call this supplier A.com. We'll hit OK. Move on to the next. We don't need to add any special envelope information when we're exchanging our data, nor do we need to do any encoding or encryption. However, we do make that as easy as selecting choices from a drop-down box. So now that we've finished creating our port, again, we're saying we've determined the destination where we want to send some information. Now we need to use that port as a part of a trading partner agreement. And again, we make that as easy as filling out a wizard. What I want to do now is create that trading partner agreement to exchange data with the marketplace that Amit's been working with. When we call these agreements, we call them channels. So I'm going to call this channel to supplier.
To supplier.
Okay. And again, we need to select the organization that we want to send the information to. We don't need to expect any receipts back or generate any receipts when we're doing this. However, we do make that as easy as checking a box. We need to indicate what documents do we want to exchange with this trading partner. In this case, we're doing the pricing and availability query. And of course, we want to log all the information, all the documents that we send to our trading partner. And we want to do that, in this case, we will do that in a native XML format. We're not using EDI or X12, which are fully supported in BizTalk Server 2000, so we don't need to worry about a group control number. And there you have it. We're done. We've created a trading partner agreement with another organization to exchange our pricing and availability queries just as easily as walking through a wizard in the BizTalk management decks. So we make these challenges, these integration challenges, as literally as easy as filling out a wizard, as using our rich graphical WYSIWYG tools to achieve these integration goals.
Wow, so that was easy. Yeah. So with a few mouse clicks, you're able to configure security, transport, address, mapping, schemas, all that stuff which you had to write so much code for, walking through a wizard in 2 minutes.
Great.
That's pretty cool.
Exactly.
Thank you.
Thanks a lot.
Great. So we've seen some of the basic challenges that you face when you build such a B2B application. Let's look at some more challenges. We've talked about quickly evolving business process. What are the technical challenges in quickly evolving your business process? Well, the business process today is spread across your partners, across your applications, across your platforms. And the other challenge is that your business process is very closely tied to the implementation. What do I mean by that? So when you write an application today, the rules of your business application are very tied in to the actual implementation. So if you have an application which says, if I get a purchase order and the amount is more than $10,000, send email to Bob or contact Bob. That code, those rules are very tied in to the implementation of contacting Bob by email or by MSMQ or whatever, or by com. And that makes evolving your application very difficult, because every time you touch those rules, you're going to touch the implementation as well. And that means more code you touch, more code you have to test, more fragile code. And wouldn't it be great if you could separate the business process from the implementation and independently manipulate each, and allow the people who really understand the business process to manipulate that independent of the implementation. And the .NET solution gives you a set of tools and a language, which I'll talk about in a minute, which allows you to separate the business process from the implementation details. It allows people who are very familiar with the business process and the rules to manipulate them independently of the developers who are very familiar with the implementation. And we have a visual design environment which brings this all together as appropriate. So the language which enables all this to happen is Xlang. Xlang is at the core of BizTalk orchestration. And Paul mentioned that in his keynote earlier this morning. It's an XML-based language. It has a rigorous mathematical foundation, which allows us to describe any process and connect to integrate applications which run across any protocol on any platform. Xlang, at its heart, is about integration. The core idea behind Xlang is that you have all these services. You have web services, you have components, you have queues. And they're all very loosely coupled, and they all need to communicate with each other. And so you need to describe that communication between these loosely coupled message-based systems in a very easy way, while keeping your business process, the description of these rules, independent from the implementation details. So Xlang is this language about communication between different systems, between web services, components, queues, etc. So I'm going to show you a quick demo of a tool which enables that to happen. Okay, so the tool you're looking at is the BizTalk Application Designer. And as you can see, the BizTalk Application Designer is built on Visio. Why Visio? Visio is the most popular tool used for business diagramming today. And what we've done is added Xlang capability into Visio. We've built it into Visio. And what that means is now you can build your application, your business application, in this rich graphical environment and generate Xlang directly out of it. On the left, you see some shapes which allow you to describe your business process. You have actions, you have decisions, you have forks, joins, etc. And on the right, you see some components that you can use. So let me actually go ahead and quickly design a business process. And the first action is receive price and availability. And this is the price and availability request I got from the user on his computer. And the next action is ask supplier A. And I can very quickly connect these actions together simply by drawing an arrow between them. And I can keep going through this process, and very quickly I end up with a business process which looks like this. The first process you saw when I went to the screen, so it's no surprise. But what you see right now is an abstract business process. And what do I do if I want to connect this process to a web service? A web service which might have been developed in Visual Studio.NET, which is a great environment for developing web services. Let me show that to you. So here is the same business process. And on the right, you see an icon for a web service. So what I'm going to do is drag a web service out onto my screen. And the question I'm asked is enter the URL where you want to browse for web services. So I enter www.biztalk.net. suppliera.com. And now an interesting thing happens. I see all the web services at that site. And the tool presents all those web services just as it would COM components. So one of the nice things about this tool is that it presents a very familiar methodology to me. I want price and availability, and I want the purchase request, so I hit finish. And at this point, on my surface, I have a representation of the web service I want to communicate with. Next, I say I want to connect Ask Supplier A, this action, to this port. And since I want to call it, I say yes, okay. And what you see is that the tool has automatically filled in the data and the types that I'm going to exchange with this web service, making it all very, very easy for me. I hit OK and I'm done. And as you can see, there's a request-response interaction happening. Let me point out a few interesting things here. On the surface, on the left side, you see the abstract business process. As you can see, there is no detail about how that is implemented. And on the right are all the components and implementation details. And the way they're connected is by these two concepts we call ports and messages. A port is this guy right here. A port is a location to which I send a message or receive a message from. Okay, it's an abstract location. And the right side of the page, the implementation side, provides the translation of that port into actual implementation. So the web service case, the port binding, as it were, would say the binding is http://www.suppliera.com. And then the message is the actual payload. Okay? So it's the XML schema. Now what you're looking at with the web service icon is a very early release of the tool, and you don't have that in the bits you have with you today. So I'm going to switch back to the current release and show you how you can build business processes using the bits you have with you. So, excuse me a second. Strategically misplaced water bottle. So, one of the great things I like about this tool, about this language, about this technology, is that I've been working with COM, just like you, for a very long time. And COM and component technology is all about reusable components. You have this sea of components out there that you need to reuse. And wouldn't it be great is if you had an easy-to-use tool which could stitch together these components. You say, I want to call this component, then this component, then this component. So I don't have to deal with all the IIDs and class IDs and all the COM goo that I need to deal with today. And wouldn't it be great is if I could build reliable and scalable and high-performant business applications using a tool which allowed me to quickly stitch together all this stuff. And one of the reasons why I'm really excited about this is I believe the orchestration tool allows me to do that in a very rich way. So let me show you binding to COM. Before I do that, orchestration allows you to do two things with COM components. You can invoke a COM component, just like co-creating it and then invoking a method on it, or the orchestration engine can behave as a COM component. And that's an interesting concept. You can act as any method on any interface as long as you have a type lib that defines the interface and you have automation types that are used in the method signature. Okay, so I can call any component, I can receive calls as any component. So let me drag out a COM component onto the screen. And here the port I'm going to define is get P_A. The question I'm being asked is, who instantiates this component? I'm going to say the orchestration engine. And again, you see a very similar tree view of all the components available to me. And I go back to the same component I used earlier in my demo, the price and availability. The other questions I'm asked are, what is the security you want in this interaction? And finally, does this component hold state? And this is an interesting question. And remember, I'd ask you to remember this question for later on in the demo, and it'll become relevant later on. I hit finish, and at this point I have, again, the component on my page. So to connect the action to this port, I again draw a line. I want to receive the call, so I pick this. And again, you see I've got all these types and variables already populated by interrogating the type life directly. And I'm done. Again, I have a synchronous request response sort of interaction with COM. Now, next I want to show you how do I bind an action to the channel and port that Dave showed you earlier in the demo. I want to do this rich messaging with transformation and security and reliable messaging with my trading partner. Before I do that, I'm going to modify this process in a very slight way. Notice that asking supplier A and asking supplier B are single actions. Specifically, that I do a synchronous interaction with them. Now, it might be that supplier A takes his time in responding to me, right? I send him a request, and he thinks about it, maybe for an hour, and sends a response back to me. And do I really want to be sitting there synchronously blocked on this call, waiting for a response back from him? Probably not. Maybe I want to asynchronously break this call into 2 message interactions. I send him a message. Sometime later, I get a message back. This also allows me to use reliable messaging. So what I do is I simply delete this connection. The second action is reply from A. And at this point, I'm sending a message out to A, and I'm getting a response back at some point. Now, how do I describe the connectivity to the channel and port using BizTalk messaging that Dave just talked about? I drag a shape out. And again, I walk through a wizard. And it asks me, what is the port you want to communicate with? And I say, supplier A. Do I want to send or receive? Clearly, I want to send a message. Select a message queue. And the queue I want to send through is channel to supplier A. And this is the channel that Dave configured earlier in the demo. Do I want security on it? In this case, I'm going to say no, and I hit finish. And again, I have a representation of that channel to supplier A. And again, I connect my action to that port. And what you see now is a dialog box that says, what is the message you're sending him? What do you want to call it? Certainly it's going to be price and availability. And I can also optionally describe the schema which this message conforms to. And I'm going to pick the Rosetta Net query schema. I hit OK, and I'm done. In a very, very similar way, I can connect up the remaining actions. And I end up with a business process which looks like this. And what you're seeing is, on the left, a business process, an abstract business process. It's a very simple sequence for now. I have some ports in between which describe the connectivity from this abstract business process to implementation details on the right. And notice that I'm calling COM, and I'm calling BizTalk messaging, and optionally script or MSMQ, and my business process on the left doesn't change. But so far, what I've shown you is how to draw the business process. Right now, it's just a pretty picture on your screen. How do I actually generate Xlang from this? Well, I go to File and say Make Xlang. And a visual compilation has just happened. We have technology built into this tool which will take the picture, compile it, and generate Xlang out of it. And let's look at the generated Xlang code. Not this. And what you see here is two parts, a schedule and a binding. A schedule corresponds to the left side of the page, the abstract business process you just saw. The binding is the implementation details. So let's walk through the schedule. In the schedule, you see a simple declaration of the ports and messages. These aren't definitions, just declarations. I'm going to be using these ports, here are their names. I'm going to be using these messages, here are their names. Following that declaration, I have sort of the business end of my business process. So now what you're looking at is a simple sequence, you see this tag here, followed by a synchronous block. Now remember, I modeled the way I interact with COM using a synchronous request-response interaction. And so that's what you see here. You see synchronous, you see a sync, as in I'm receiving a method call, and a source, I'm sending a response back. Okay? So I have a synchronous here. That's followed by a simple source, which is sending a message. This is the ask supplier A action, where I'm sending the message price and availability, P and A, to the port send to A. Okay? And similarly, I have similar sinks and sources in the rest of the sequence. So that's the schedule part of it. Let's take a look at the binding. And as you can imagine, because the binding has a huge amount of information about implementation details, about schemas, in the case of COM, about IIDs and class IDs and type libs and field values and field types, the binding information is pretty substantial. So here are some references to the schema, and I'm going to scroll through this. And let's find an interesting port translation to show. Here you go. So the port translation for send to A, remember, I am sending through a queue, through BTS, through BizTalk messaging. And what you see here is my tag for my queue name, a unique identifier for the queue, and a unique identifier for the message. In addition, there's a declaration of the message and the type it conforms to. Okay? Let's scroll up and see the binding to COM. Here we go. In the COM case, I've got the expected stuff. I've got an IID, I've got a class ID, I've got declarations of what the method signature is, I've got declarations of what the method number is. So what you've seen is a tool which allows me to easily create my business process and then bind it to component technology using BizTalk messaging, using COM, using MSMQ. Let's continue to look at your challenges. So I've got this very simple sequence. And now what I need to do is I need to make it reflect the needs of my business process. I need to make it robust. I need to make it reliable. And because I'm dealing with all these business partners concurrently, I've got partner A, partner B, and partner C sending me messages in different orders, in different schemas. I need to be able to very easily handle all that concurrency, all that correlation. So I need to be able to define complex transactions which allow me to build reliable and scalable business processes and highly available business processes. I need to be able to deal with concurrency in a very rich way. I also need to be able to do correlation. What do I mean by this? Now again, in this asynchronous world, I have lots of people sending me messages from all over the place. And I've got lots of instances of business processes for which these messages are bound. And correlation is the process by which I say, hey, I got this message at this location. It's destined for this business process. I need to do all that matching up. And the .NET solution provides rich support for transactions and concurrency, automatic transactions, reliability, automatic persistence. And I'll talk about this feature in a minute. The BizTalk orchestration technology handles the complexity of creating highly concurrent and correlated business processes and lets developers focus on the components and building better applications. So let's get back to the demo station. So the first thing I'm going to do is I look at this business process and I say, okay, I get a price and availability request. Then I ask supplier A, and at some point I get a response back. Then I ask supplier B, and I get a response back. Why am I doing this sequentially? Is there any reason why I need to ask supplier A before I talk to supplier B? Is there any reason I need to deal with all the latency of talking to supplier A and supplier B in a sequential way? Well, the answer is no. So I want to run this concurrently. I want to run these two interactions at the same time. How do I do that? Well, let me show you how easy it is to modify my business process. I'm going to pick these two actions, drag them over to the left, delete this. Come on. Okay, the delete key on this machine does not work. Okay, that's a good idea. Let me try that. Let's try clear. There you go. Wonderful idea. Let's give him a hand. Can you stand up, please? Okay, I'll do the same thing here with the other one and this guy too. Edit, clear. Okay, so I've got these two guys hanging out in space. How do I connect them up? So I drag in a little fork and a little join. And again, I connect up the actions the same way you saw earlier. I'm going to pretty this up a bit. So you see what I've just done. I can certainly make it prettier, but the essence of what I've done is in 30 seconds, and it would have been 15 if I didn't have this little problem with delete. In a very quick amount of time, I've changed my business process in a very fundamental way. I've gone from a sequential operation to concurrency. And you all know how hard it is to deal with concurrency. Okay, as soon as you have any sort of concurrency, you start dealing with thread pools, with synchronization, with deadlocks. You end up with systems that don't scale very well. And this tool provides you a mechanism for describing concurrency very easily and having the tool deal with the concurrency issues. Now let me show you something. Oh, edit, delete again. Let me try and compile this. So I go back to File. And my visual compilation starts, and oops, I got an error. And the error says, failed to process slang schedule, flow is incomplete, nothing flows out of the shape from the bottom. So what has just happened? The visual compiler told me that the process is invalid because I did not connect the final fork to the next action. It recognizes that my business process is invalid. So I go ahead, and I'm not sure if you can see it, but the actual offending shape has been highlighted in green. I'm not sure if it's visible back there. So I go back to the offending shape, and I connect that up to the action, and try again. And this time it works. Okay. Now I have this business process, and perhaps I want to add transactions to it. And we all know that transactions are an important attribute for building reliable and highly available applications. So let me go to a similar business process. Right here. And all I've done here is I've increased the distance from the fork shape to the get, purchase, and price and availability request action. So I'm going to delete this. I've learned. And I'm going to add a new action. And this action might be, say, update your database. Okay. Okay. Today's not my lucky day. Unfortunately, the keyboard is now dead. Okay. Anyway, I can still communicate the concepts, I think, that are important without the keyboard being alive. Okay. So let's say there's an action 1, and imagine, if you will, that action 1 actually says, update database here. Okay. And I've done some binding to maybe a COM component or directly to a database. And now I want the receipt of the price and availability request and the updating of the database to happen inside a single transaction. How do I do that? Well, you see this transaction shape here? I drag it out. I right-click and say, associate all enclosed shapes. And what has suddenly happened is in 7 seconds, I've described a transaction boundary. And at runtime, the orchestration engine will enforce that these two actions happen within the same transaction. And these actions, one action could be bound to MSMQ. One action could be bound to COM. And that's very, very powerful. Okay, now remember, we talked earlier about whether a component holds state or not. I just want to remind you because it will become relevant in what I'm about to show you. So imagine a business process which is running, and you have perhaps hundreds of instances of this business process running on your machine. And you're talking to your suppliers. And all your suppliers, are taking their time to send a response back. You send a message to supplier A, and he sits on it for a day or 2 days, and finally sends a response back to you. Do you really want that business process sitting in memory, consuming your resources, while it's doing nothing? It's just waiting for a response to come back. You probably don't want to do that. And you're also now susceptible to the process failing. You're susceptible to crashes because this business process is sitting in memory. Now, this is a very common scenario. People, there are lots of websites out there which provide information to their customers, perhaps about their retirement accounts. And so these websites access legacy systems, these back-end systems. And very often what you find is that this access to the legacy system is synchronous, it's blocking. Which means that very often you run into a situation where the website can no longer accept any more connections, but the CPU is at 5%. And that's because all the connections are waiting for a response back from the legacy system. So rather than use your resources in such an inefficient manner, right, consuming resources and memory while the system itself is doing nothing, wouldn't it be great if you could take the business process out of memory, onto disk, and then when the message came back, automatically rehydrate the business process from disk into memory. We call this process dehydration and rehydration. Why is this possible? Well, it's possible because we've described the business process in this separate way from implementation, which allows us to define a schema in a database which can hold information about your process as well as any information, any data contained within the process. So we can take the application, the instance running in memory, take it out of memory, stick it on disk with no image left in memory. And when the message comes back, boom, it's back up. Now, how do you do that? That again is very simple. Let's say I want to go to supplier. Let's say I know that the action supplier A, ask supplier A, is going to have a latency of a day. Okay? So I right click on ask supplier A, edit properties, and I say I know the latency. And here I specify the latency in milliseconds. I'm not quite sure how much a day is in milliseconds. Well, it's 86 million. That's a guess. So I add a number here. Oops, my keyboard is again dead. Sorry. So imagine I added 86 million down there. I hit OK. And now when this business process runs, depending on system configuration. Now remember, this is just a hint. It doesn't mean that I will dehydrate to disk. It's just a hint to the system. And depending on system configuration, if resources are being used, heavily used, and they are needed, the system will automatically dehydrate the process out of memory. And this is completely transparent to the application and to other users. And it's very easy to create such applications yourself using this tool. Well, great. Now, what I've shown you so far is gradually building up this business process. And I've been fighting my keyboard in the process as well. Now, certainly, as I add concurrency and transactions, I also want to add error handling, branching, decisions. You know, if purchase order more than $10,000, do this, otherwise do that. And so here's an example of a real-world business process. Now, what I'm showing you is a real business process, and here you see some of the branching. This is like a case statement. And it's got connections going everywhere. It's got bindings to COM, to BizTalk messaging, to queues. And this business process is currently running at a pilot project at Dell. Okay? It receives orders from partners. It receives information from partners. It sends information to partners. And I'm going to show you this process running on my machine. Now, clearly, this is a server application. So, you know, all you're going to see is a couple of dialog boxes. Server applications are hard to demo. But here I have a test harness. And what this test harness is going to do is instantiate my business process and run it. And I click Run. And it says, click OK to instantiate the business process. I hit OK, and the business, so what has happened is an instance of the business process has been created. I run through this, communicate with my partners. In this case, I've got a dummy partner sitting on the other laptop. And finally, I get back an XML document which describes the information I wanted. In this case, it is the price and availability quote. So what have you seen here? You've seen that I can very richly describe business processes using the BizTalk Application Designer. This designer is capable of directly creating Xlang descriptions of my process, which are directly executable through the BizTalk orchestration engine. The orchestration engine can bind to MSMQ, to COM, to web services, to the BizTalk messaging infrastructure, which provides very rich capabilities, including mapping, administration, the message desk, and the schema editor, which again allows me to access my trading partners and my internal applications in a very rich, powerful, and easy way. And we also provide direct programmatic access to both the engines. In summary, orchestration allows you to easily build business processes. that integrate with web services and components and queues, that are very easily modifiable, that are very scalable and highly reliable, and that can be easily integrated with a rich set of applications and protocols. And Xlang, the language Xlang, enables orchestration. The call to action: use the code, it's in your bag, use it, play with it, use the application designer to define your business processes, to bind to components, to web services, to queues, to BizTalk messaging. Use the schema tools for mapping, for creating schemas. There are 4 other sessions at the PDC about BizTalk, and I would highly encourage you to attend them. There are detailed sessions about the tools, the mapping tools, the detailed sessions about the application designer. Download the beta. It will be available later this summer. And here are the list of the related sessions. Now, I hope you are as excited about this tool and this technology as I am, because I really believe this allows us to create very powerful, very rich business applications ready for the internet today. Thank you.
Ladies